The inspectors claim that number 10 wire cannot be on a 60 amp breaker is not always correct. National Electrical Code Section 215.2 F3 provides an exception to the general rule. This section states that where the ampacity of the branch circuit calculated by Part Roman 3 is greater than the ampacity of the branch circuit short circuit and ground fault protective device permitted by Part Roman 2, the ampacity of the branch circuit short circuit and ground fault protective device shall be permitted to be equal to the ampacity calculated by Part Roman 3 provided all of the following conditions are met. Firstly, the ampacity of the branch circuit short circuit and ground fault protective device does not exceed the ampacity of the branch circuit conductor. Secondly, the setting of the branch circuit short circuit and ground fault protective device is sufficient to provide the required short circuit and ground fault protection for the equipment connected to the branch circuit. And thirdly, the branch circuit is protected by a supplementary overcurrent protective device rated in accordance with the ampacity of the branch circuit conductors. In this specific case, number 10 wire, according to table 310.16, might have an ampacity greater than 30 amps, especially if using conductors with a high temperature rating like 90 degrees Celsius, assuming the terminations are also rated for 90 degrees Celsius. The 60 amp breaker, serving as the branch circuit short circuit and ground fault protective device, must not exceed the ampacity of the branch circuit conductors. The 60 amp breaker setting must be sufficient to provide the necessary short circuit and ground fault protection for the compressor connected to the circuit. Crucially, a compressor motor must have a supplementary overcurrent protective device, such as an overload relay, rated in accordance with the motor's nameplate amps, which is 24 amps in this situation. The purpose of the supplementary overcurrent device, the overload relay, is to protect the motor from overloads, which are different from short circuits or ground faults. Overloads are typically smaller increases in current that last for a longer period. The overload relay is designed to trip and disconnect the motor from the power supply if an overload condition occurs, preventing damage to the motor windings. In summary, the installation can be compliant with the National Electrical Code if firstly, the number 10 wire has an ampacity of 60 amps or greater, considering conductor temperature rating and termination limitations. Secondly, the 60 amp breaker is providing short circuit and ground fault protection. And thirdly, the compressor motor has an overload relay set at or near 24 amps to protect the motor from overloads. It's essential to perform the calculations according to National Electrical Code Article 430, which covers motors, motor circuits, and controllers. This article provides specific requirements for sizing conductors, overcurrent protection, and control devices for motor applications. The motor's nameplate provides critical information needed for these calculations, including the full load amps, voltage, and service factor. To properly size the motor circuit conductors, refer to National Electrical Code Section 430.22, which generally requires conductors supplying a single motor to have an ampacity of not less than 125% of the motor's full load amps. In this case, with a full load amps of 24 amps, the minimum conductor ampacity would be 24 amps times 1.25, which equals 30 amps. This means that the number 10 wire, with an ampacity of at least 30 amps, meets the minimum requirement for the motor circuit conductors. However, it's important to consider any voltage drop requirements and adjust the conductor size accordingly to minimize voltage drop. To determine the appropriate size for the motor circuit short circuit and ground fault protection, refer to National Electrical Code Section 430.52. This section provides tables and guidelines for selecting the maximum rating or setting of the overcurrent protective device. The type of motor and the type of overcurrent device used will affect the maximum allowable size of the overcurrent protection. For example, an inverse time circuit breaker may have a different maximum allowable rating than a fuse. It's crucial to consult the appropriate tables in National Electrical Code Section 430.52 to determine the correct size of the overcurrent protection for the specific motor and overcurrent device used. The overload protection for the motor is provided by the overload relay as required by National Electrical Code Section 430.32. The overload relay is designed to protect the motor from overheating due to overloads, as previously mentioned. The overload relay should be selected and set according to the motor's nameplate, full load amps and service factor. The overload relay's trip current should be set as close as possible to the motor's full load amps without causing nuisance tripping. It's important to coordinate the motor circuit components, including the conductors, overcurrent protection and overload protection, to ensure proper protection and operation of the motor. Performing the calculations according to National Electrical Code Article 430 and selecting the appropriate components will help to ensure a safe and compliant installation. Remember to always consult the latest edition of the National Electrical Code and follow all applicable local codes and regulations. If there is any doubt about the correct way to install or size a motor circuit, consult with a qualified electrical engineer or electrician. Providing the inspector with the calculations and code references will help clarify the situation and demonstrate compliance with the National Electrical Code. Also, it may be helpful to have the motor's nameplate information readily available for the inspector to review. This information will help the inspector verify the motor's full load amps and other relevant data needed for the calculations. In addition to the code requirements, it's also important to follow good electrical practices when installing a motor circuit. This includes ensuring that all connections are tight and secure, using properly sized wire connectors, and grounding the motor and equipment according to code requirements. A well-installed and properly protected motor circuit will provide reliable and safe operation for many years. Another consideration is the motor's duty cycle, which refers to how often and for how long the motor is expected to operate. If the motor is subject to frequent starts and stops or operates continuously for extended periods, it may be necessary to increase the conductor size or use a motor with a higher service factor to prevent overheating. The motor's service factor is a multiplier that indicates the motor's ability to handle occasional overload without overheating. A motor with a higher service factor can typically handle more demanding applications. When selecting a motor for a specific application, it's important to consider the duty cycle and service factor requirements to ensure that the motor is properly sized and can handle the expected load. Furthermore, the ambient temperature in the location where the motor is installed can also affect the conductor ampacity. If the ambient temperature is higher than 30 degrees Celsius, it may be necessary to apply a correction factor to the conductor ampacity as specified in National Electrical Code Table 310.16. This correction factor reduces the conductor ampacity to account for the higher ambient temperature. It's important to consider the ambient temperature when sizing conductors to ensure that they can safely carry the required current without overheating. In addition to the National Electrical Code requirements, there may be local codes or regulations that apply to motor installations. It's important to check with the local electrical inspector or building department to determine if there are any additional requirements that must be met. Local codes may vary depending on the jurisdiction and may include specific requirements for motor disconnects, wiring methods, or grounding. Following all applicable codes and regulations will help to ensure a safe and compliant installation. In summary, when installing a motor circuit, it's essential to consider the motor's nameplate information, the duty cycle, the ambient temperature, and all applicable codes and regulations. Performing the calculations according to National Electrical Code Article 430 and selecting the appropriate components will help to ensure a safe and reliable motor installation. Communicating with the electrical inspector and providing them with the necessary information will help to resolve any disagreements and ensure compliance with the code. Remember that the primary goal is to protect the motor from overloads and short circuits while also ensuring the safety of people and property. By following these guidelines, it is possible to achieve a safe and compliant motor installation. Always prioritize safety and consult with qualified professionals when in doubt. The inspector may not have a full understanding of the application of Section 215.2 AFI in this particular case, especially considering the presence of the overload relay and the compressor motor. By presenting a clear and well-documented explanation of the code requirements and the specific characteristics of the installation, it's possible to address the inspector's concerns and gain approval for the installation. Remember that electrical codes are constantly evolving, and it's important to stay up to date with the latest revisions to ensure compliance. Continuing education and professional development are essential for electricians and electrical inspectors alike to maintain their knowledge and skills.